Welcome to the Deep Dive. We're here to take a dense stack of sources, all the research, the tech specs, the breakdowns, and really pull out the critical knowledge you need. Today, we are diving into the technical guts of a really fascinating piece of coffee tech, the Kaleido Sniper coffee roaster. We've been looking at a deep analysis of its hardware, its engineering, and really the specific choices the designers made to tackle some of the biggest frustrations in home roasting.
Right.
So, our mission today is to decode how this machine aims to make roasting, which has always been this really complex art, not just accessible, but precise.
Ruthlessly precise.
We're going to explore how they claim to bridge that massive gap between someone who's just curious, just starting out at home, and a full-on professional barista.
And that philosophy that's laid out so explicitly in the source material we have.
It is, isn't it?
Yeah, the core goal for Kaleido Sniper is to fundamentally enhance the coffee experience. It's about empowering people, specifically you at home, to get exceptional coffee and to get it consistently.
So it's not just about a lucky shot.
No, not at all. They promise this by focusing on, and this is their term, verified technical functions. Basically, essential features that are designed from the ground up for a perfect roasting experience. It's a really ambitious attempt to democratize that pro-level control.
Okay, let's unpack that. When we talk about roasting, it all starts and ends with the heat.
Always.
For serious enthusiasts, the heat source is traditionally a trade-off. You get either the stability of electric coils, maybe, or the responsiveness of gas, but it's rare to get both.
You usually have to pick one.
So what makes the heating system in this roaster so special? Why did the engineers go down this specific path?
Well, what's so innovative here is that they moved away from all those conventional elements. They just leapfrogged them entirely and went straight to electric carbon fiber infrared heating.
Infrared, okay.
And that is a crucial distinction. I mean, traditional electric heating is often slow. It relies on convection, so you're heating the air, which then heats the drum, which then finally heats the beans.
That sounds like a long and inefficient game of telephone for heat.
It is, and that whole process leads to a major quality issue called tipping.
Tipping.
Yeah, that's when the outside of the bean, the tip, heats up way too fast while the inside is still lagging behind. You get this uneven development, a splotchy, mottled look.
Not what you want.
Not at all. But this carbon fiber infrared system, the sources describe it as having unique penetration performance.
Unique penetration performance. That sounds like it's tackling that speed versus quality problem head on. Is it basically driving the heat deeper and faster?
Precisely. Infrared transfers energy directly to the object, so it's getting deep into the bean structure very quickly, which helps the core temperature rise in sync with the surface temperature.
I see.
And that's absolutely essential for uniform development, which is, the holy grail of good roasting. It lets you hit your first crack much more evenly across the entire batch of beans.
And there's more to it than just the quality of the roast, right? The sources highlight another advantage, the economics of running something like this at home. That matters.
It absolutely does. The material points out that this infrared tube technology achieves an innovative breakthrough. You get low energy consumption paired with really high thermal energy output.
So you're not going to be blowing your circuit breaker every time you want to roast some coffee.
Exactly. You're getting the intensity and the rapid response you need for high-quality roasting, but you're not getting the massive power drain you'd associate with, say, an industrial heating system. It makes it viable for a standard home kitchen.
Okay, so we've got this intense, rapid, deeply penetrating heat. But that immediately brings up the next big challenge in roasting: uniformity.
Always.
If the heat is that powerful, how do you stop it from just scorching the beans closest to the element while the ones in the middle are still, trying to catch up? How is all that power distributed evenly?
And that brings us to the drum design, which is really the perfect counterbalance to that intense heat source.
Okay.
They use what they call a flexible drum. And to be specific, it's an enhanced high-speed steel mesh bean drum.
A mesh drum?
A mesh drum. Now, if you look at a lot of older roasters, both home and commercial, they use solid steel drums, and those reflect heat, they impede airflow, they cause hot spots.
Right, a solid drum traps that air and heat unevenly. The beans are basically just relying on conduction, just bouncing up against hot metal.
Exactly. But the mesh structure is a critical function here. It ensures a uniformly heated process because it allows for both radiant heat from that carbon fiber element and massive convective airflow circulating right through the beans.
Ah, so it's a two-pronged attack.
It is. It maximizes the exposure for every single bean in that batch. It guarantees this sort of comprehensive three-dimensional development.
And there's a practical side effect to this too, right? For the user.
A huge one. This uniform heating has a really valuable secondary benefit. It helps with the separation of pulp from chaff.
Let's clarify that for anyone who might be new to this. What exactly is chaff, and why is separating it so important?
Sure, chaff is that thin, papery skin that covers the green coffee bean. As the bean heats up and expands during the roast, that skin naturally just flakes off.
Okay.
Now, if that chaff isn't separated and exhausted quickly, it can fall back onto the heating elements or just smolder inside the drum, and that leads to these acrid, smoky, off flavors in your final cup. It also just makes a huge mess.
So a drum that helps blow it away is a cleaner process.
And it means a cleaner, brighter final flavor. It's really elegant, actually. The design serves both thermal uniformity and, the cleanliness of the roast.
That is elegant. Okay, here's where the tech gets really interesting, especially for experienced roasters. Because in roasting, knowing the exact internal temperature is everything.
It's the whole game.
But any pro will tell you that the reading you get from your temperature probe is super sensitive to where it's placed.
Oh, absolutely.
If it's fixed near the heating element, it might read, say, 400 degrees Fahrenheit. But the actual temperature inside the bean mass could be way behind, maybe a 375 sample. It's called temperature stratification.
A chronic problem.
So how did the engineers solve that? How did they fix the problem of getting different readings depending on where the probe is?
This is one of the most exciting technical breakthroughs mentioned in the sources, and it speaks directly to control. They looked at the problem and realized the innovation didn't need to be in the probe itself.
The thermocouple.
Right, a standard K-type thermocouple is reliable. The problem was the rigid mounting mechanism.
So they focused on the hardware that holds the probe.
Correct. The design has the specific mechanism. A screw-free, self-locking probe holder.
Screw-free and self-locking. Why is that so critical?
The benefit for you, the user, is that this mechanism lets you easily and very precisely adjust the depth of that probe into the roasting environment.
That is a massive deal, especially for people at home who roast different batch sizes.
Exactly.
I mean, if I'm doing a small half-pound test batch, the critical thermal mass is much shallower than if I'm roasting a full, say, 1.5-pound batch. A fixed probe would totally mislead me in one of those scenarios.
It would render your data almost useless. I mean, when you're using sophisticated software like Artisan or Cropster, you're tracing these curves. But the curves are only useful if your measurement point is consistent and meaningful.
Garbage in, garbage out.
Precisely. If the machine dictates a fixed, possibly misleading reading, you can never replicate that perfect roast. By giving you simple, screw-free adjustability, they remove the machine as the source of error and put control back in your hands. You decide where that critical temperature point is.
Which means the roast profile you see on your screen is a true reflection of the energy the beans are absorbing.
Yes, not just the heat coming off the drum wall. It transforms the measurement from sort of an arbitrary reading to an adjustable, accurate target.
That degree of control really moves this machine out of the gadget category and squarely into the serious tool category.
It really does.
All right, let's move from precision to efficiency. Let's talk workflow.
Okay.
If you're roasting seriously at home, you're probably doing multiple batches, especially if you've got friends and family hitting you up for coffee.
The neighborhood supplier, yeah.
And the post-roast workflow is often the biggest bottleneck. You have to cool the beans incredibly fast to stop them from continuing to roast. That's called coasting. How does this roaster handle that time-sensitive transition between batches?
So the essential solution here is the independent cooling system. And a rapid cooling system is just fundamental. It prevents that coasting, that unwanted development that can turn your perfect medium roast into an overdeveloped dark roast in like 60 seconds. You have to hit the brakes and hit them hard.
And what does the hardware look like to get that instant stop?
The cooling hardware is, it's robust. Depending on the capacity of the model you get, the engineers put in either 2 or 4 high-powered cooling fans, so they're ensuring there's more than enough airflow to drop that temperature fast.
But doesn't that much airflow mean A massive, noisy fan. Is that a practical trade-off for an appliance that's sitting in your kitchen?
That's a fair point. Noise is usually the compromise. But the real advantage they emphasize here isn't just the power of the fans, it's the independence of the system.
Independent.
The cooling system is designed to operate completely on its own. It doesn't share airflow or circuitry with the heating element or the drum motor.
Okay, so what does that mean for my workflow?
It's transformational. It means as soon as your roasted beans drop out of the drum and into that cooling tray, you can immediately charge the next batch of green beans into the drum and start preheating.
Wow. Okay, that changes the game for batch roasting.
It does.
Anyone who's done more than 2 batches knows the agony of waiting for the whole machine to cool down before you can safely start the heating cycle again.
Yeah.
This independence thing sounds like it could save, what, 5 to 8 minutes per batch?
Easily. And over an afternoon, that's maybe 30, 45 minutes of wasted time that's just gone, eliminated.
That's the competitive advantage right there.
It is. And if we connect this back to that mission of bridging the gap to professional baristas, what do pros do? They value high throughput and absolute consistency across batches 1, 2, 3, and 4. An independent cooling system gives both of those things to the novice by getting rid of that downtime. It allows for true chain roasting at home.
Now, let's address the elephant in the kitchen. Smoke.
The big one.
Roasting produces a lot of smoke and smells, especially as you get into darker roasts. For a home appliance, what does this mean for your kitchen or your garage? How does it manage that smoke?
They approached the smoke exhaust system pretty pragmatically. They acknowledged the limitations of physics in a small machine.
So they didn't promise the impossible.
No. Generally speaking, the built-in extraction system is designed to handle the smoke from a typical light to medium roast. It should remove most of it through its standard internal filtration. That's the baseline you'd expect.
But as you say, if you're pushing into big batches or really deep, oily, dark roasts, that smoke volume just goes up exponentially.
Exactly. And the sources are honest about this. They acknowledge that for large capacity or deep roasting, there is still an inevitable problem of smoke exhaust. You can't just defy physics on a countertop.
So what's the fix?
They included a specialized but very practical solution, a special smoke exhaust pipe. The user can just attach this pipe to the roaster, and it lets them vent that heavy smoke away, out a window or into a proper range hood.
So it's an add-on for extreme use cases.
Right. It's an acknowledgement of the limitation. You can't filter all that heavy smoke internally paired with a practical external solution for when you really need to push the machine.
It's smart.
It is smart. Handle the daily use cases internally and provide a verified solution for the extremes rather than trying to engineer some massive industrial fan into a small home appliance. It keeps the machine accessible but still scalable.
Exactly.
Let's bring this all full circle then, back to that mission of democratizing professional level control. We've looked at the sources and we've really identified 4 main technical areas.
We have the rapid carbon fiber infrared heating, which solves that uneven development problem. We have the uniform mesh drum for total bean exposure and cleanliness, the adjustable temp probe, solving the measurement consistency problem, and the quick turnaround independent cooling system, which solves the workflow bottleneck.
That's the perfect synthesis of it. Every single one of those technical features is specifically designed to eliminate one of the core variables that trips up a novice roaster.
The things that make you want to give up.
Totally. Uneven heat, bad temperature readings, slow batch turnover, smoke everywhere. These are the stumbling blocks. By addressing them with specific mechanisms like that carbon fiber element or the screw-free probe holder, they're basically installing a layer of professional control and predictability right into the machine.
So you're spending your time focusing on the art of the roast profile.
Yes, the sight, the sound, the smell, instead of fighting the physics of your own equipment.
And the sources really emphasize that these aren't just marketing bullet points. They note that these functions have been rigorously tested, verified, and upgraded from one generation to the next.
Absolutely. They're refining the core elements to maximize control. And this brings us to our final provocative thought for you to think about.
Okay.
We've seen how this design successfully tackled heat, cooling, measurement, and smoke, the big environmental and thermal variables. But what is the next inevitable technical hurdle in coffee roasting? Beyond these fundamentals, what's going to define the next generation of high-performance home equipment?
That's a great question. Is it something like humidity control inside the drum? Or maybe an even more granular sensor, something measuring mass or density changes in real time? What's the problem that's so subtle that only the most dedicated roasters even see it now, and how will engineers tackle that next layer of precision?
Something to think about while you're enjoying your perfectly roasted coffee. We'll see you next time for The Deep Dive.